Today at Berkhamsted we're doing our biannual inter-house competition for design and technology, where students are given the opportunity to design and model a prototype drone to collect as much plastic waste as possible.
We're kind of in the beginning stages of it, but I think it's going to be a pretty good idea.
We're going to make a kind of catamaran with a net in the middle to pick it up.
Then in the middle of this we'll have another flat foam board here. Underneath that we'll use the net that we were given. When the balls go underneath it will keep it buoyant.
So then we're going to cut out like a shape here so that the balls can float into the net, and then we're going to have string that we pull back and hook so that the balls don't fall out.
We've looked over some different ideas to add to it and like change it a bit.
Thinking about how we can use the materials to our advantage. We've added straws and styrofoam underneath and around the edges to keep it more flow.
After about 8 different versions of it, we came to design where you'd have an open mouth that has a diverger, so the balls would go in and divide into 2 different bags at each side. And due to the balls floating, so it wouldn't actually push our design up, they'd just come out as buoyancy aids on the side.
We think it did perform because it did gather a lot of balls, although we have made some adjustments to it so far.
We came across a problem. We had originally we had a lolly stick in between, but that stopped the balls from going through, so we just adjusted it, took the lolly stick out, and we've been able to let it flow a bit more freely, and a lot more balls have gone through into the HMS Fry's boat, so I think we're getting the grip of it.
We wanted it to split into 2 lanes. That's sort of stopping where the balls are supposed to go. They don't go in as easy, we need something for them to push against a bit more at the sides. And we managed to collect 2 pretty quickly, and then about 4 this go. The netting works well when it comes to collecting and keeping them in there, along with the aerodynamic, water dynamic version of being able to glide quickly through the water, as it's very pointy and lets the water go past it. The extended scooping zone has helped keep the balls in there a bit more than it did before, or they wouldn't even go in. So there's an improvement in that point.
Managing to measure everything correctly, that all comes in handy. Using scalpels, stuff like that, hot glue guns.
Managing how much you have at that moment when it comes to glue, it's
and only using certain resources.
And how, in theory, something works, but turns out it might not.
Actually, we don't really work with Year 8s for Year 9s, so I think that's a pleasure to work with them. Discovering what people are often more confident in, what people just feel less confident. So I just think getting to know the whole group as a whole.
The more you work together, the more productive you become, and then it allows you to achieve better things.
You would have to adjust as you do it, slightly in places, but have multiple versions to fall back on.
So it was actually work. It's all about plastic and reducing plastic in the ocean. And what better way to do it than make it a competition? So that's what it is. So instead of actual plastic, we're using plastic balls.
Following the process, we've seen a whole multitude of really good, promising designs. The winners were able to create a design that actually encapsulated this iterative process that we really strive to find in design and technology. The overall winners themselves were adders. It was great to see the working together as a team. They showed innovation in their particular design, and that the model was a high quality, using a range of different tools and processes. Overall, we felt that all students took away a lot of transferable skills, and hopefully we'll be selecting design technology in the future.